Hello everyone. Just a reminder, if you haven't subscribed, please subscribe so you can have updates. Let's solve problem number 2. Find the three distinct roots of the equations 8c cubed plus 27 equals 0, where c is an element of complex numbers. Giving your answer in modulus argument form. You have to take note of that detail needed, which is the answer must be in that form. So for letter A, we will simply use our GDC. You go to menu, you go to menu, algebra, polynomial tools, find roots, and then you enter the degree, 3, and then the roots, you make it complex. This will give you these answers, 3 roots. By the way, you have to include a coefficient, 8, then 0, then 0. So this is for the cube, for the squared, for the x raised to 1, and our constant is 27. So when you encode this, you will get the roots, the 3 roots of the equations, which are, okay, let's label it as c sub 1 equals negative 3 halves, c sub 2 equals 3/4 minus 3 square root of 3 over 4i, and c sub 3 equals 3/4 plus 3 square root of 3 over 4i. Okay, the answer looks fine, but again, it must be written in modulus argument form. These are written in Cartesian form. So it's very simple. You don't need to do this by hand. You just use your GDC. You can go to menu, number, then complex number tools, and then after complex number tools, you can write magnitude. Okay, so in the magnitude, what will appear in your calculator or the vinculum, you just have to enter 3/4 minus 3 square root of 3 over 4i. This will give you the magnitude of your z sub 2 as 3 halves. And then to get the polar angle or the angle instead of magnitude, so same number, complex number tools, but you write polar angle, and then what you will have is the argument of c sub 2, which is equal to negative pi over 3. So you do the same for c sub 3. Now, other than this, okay, you can simply write in your calculator 3/4 in the screen, 3 square root of 3 over 4i, and then you go to menu, number, complex number tools. So after the number tools, you click convert to polar. Okay. Okay, this will give you e negative pi over 3i times 3 halves. So this part is the magnitude and this part is the angle. So you do the same for c sub 3. Okay, so now knowing all this, we can already write our final answer. C sub 1 is simply negative 3 halves. It's zero angle. So C sub 2 is 3 halves C's cosine I sine negative pi over 3. And then C sub 3 equals 3 halves. They have the same magnitude. C's but different angle, pi over 3. Okay? Okay, let me have some space here. Let me erase this. So read the next problem. We are asked to prove that the area of the triangle whose vertices are the complex numbers is equal to 27 square root of 3 over 16. So we can, let me write here, okay, let's represent that Argand diagram where this is your ray and this is your imaginary. For C sub 1, it's negative 3 halves. So 1, 2, 1, 2, 3. So 3 halves is 1 and 1 half. So that's your C sub 1. What's the equivalent of, let me just find the decimal of the other one. 3 square root of 3 divided by 4 is around 1.3. So let's say this is 1 here. So if we represent C sub 2, 1, so it's around probably here, C sub 2, and then its conjugate is directly above it, C sub 3. Now we form a triangle using these vertices. Let's say, okay class, this is not drawn to a scale, so bear with the drawing. Okay, so what we can do is, so probably start from the center. Let's call this our, I just rename this for easy identification. Let's have this A, let's call this C. This is ABC, and this is O here. So from O, we can have 3 angles. Why nothing blue? Let's make it blue. Yes. A, and this one. So this, we have 3 angles. We need to find, we can use the formula of triangle, area of triangle equal to 1/2 AB sine C, where this is the included angle and A and B are the adjacent sides. So we know this is the magnitude of Z cube. Magnitude is 3/2. It's shown here. And then this distance is also 3/2. And this distance, although it's not drawn to scale, is also 3/2. That's the distance. So this is equivalent to our OA, OB, and this is OC. Now for the angle, got this class, we know this to be pi over 3. Although this is negative pi over 3, then the negative there is simply about the direction of the angle, but this angle is equal to 2 pi over 3. So our angle AOC, AOP is 2 pi over 3. And this angle here, class, okay, which is angle COA, is also equal to 2 pi over 3. It would be pi, so pi minus this pi over 3 is 2 pi over 3. So minus pi over 3 equals 2 pi over 3. And for angle COP, it will be, the whole circle is 2 pi, right? So the whole thing is 2 pi, and you are removing 4 pi. So from here to this part, it's 2 pi. So 2 pi, you remove the angle AOB and angle COA, which is 4 pi over 3 in total. That gives you 2 pi over 3. Now, to use this area of a circle, then we have triangle AOB is equal to 1/2 of 3 halves and 3 halves times sine of 2 pi over 3. Okay, if your calculator gives you the decimal, you must give the exact. So you just remember your unit circle, right? Unit circle. So this is your pi over 3, and this is 2 pi over 3. So they have the same sign. Yung the coordinates of pi over 3 is, the coordinates are 1/2 and square root of 3 over 2. So this is our sine 2 pi over 3. They have the same. It's a property. So it's the same as 1/2 times 3 squared times 3 squared times square root of 3 over 2, which is the same as 9 square root of 3 over 2. Now, our angle, our triangle, where can I write that? So let me just simplify this. This is equal to 9 square root of 3 over 16. Sorry, it's 16. 2 times 2 times 2 times 2 is 16. Okay, so let me erase this. Our angle or triangle COA will have the same area. 1/2 times 3 halves times 3 halves times square root of 3 over 2. So that will give you 9 square root of 3 over 16. And our triangle COB also have the same area. 1/2 times 3 halves times 3 halves times square root of 3 over 2. So that gives us 9 square root of 3 over 16. So if you add all of this, or if you multiply 3 by 9 square root of 3 over 16, that leads us to 27 square root of 3 over 16. So it has been proven. Stand by for problem number 3.